let's start with big data plus Hadoop plus something question mark. Then we'll see what is this question mark. Any guesses? Okay, fine. So what we'll do is like before we start, just read this slide yourself. Okay. So whatever is presented over here, you can actually check it out on your mobile phone or maybe on your laptop. I have not tested the mobile phone. On some mobile phone it's working, so on some it's not working. On laptop it's definitely working. You can see, there are some machines that have already been configured. So you can have a look at it. Right? So what shall we cover during this session? One will be like, obviously we'll have a prerequisites. If you think you are not qualified, you can just go back and continue with your work. No issues in that. Okay? We'll introduce big data, like what is big data, what are the types of big data, the use cases. After that we'll cover Hadoop and maybe some good things later on. Oh, okay, so these are the prerequisites. You need not know anything about big data. Okay, this presentation is just basically the basics of big data. It's on a very basic level, targeted more towards the audience. Like the client servicing CDMs who can actually go out, pitch, and you can show off your big data knowledge after you have gone through this presentation, right? And yeah, some level of patience, please. Some concepts will be there. So what is big data? Tell me. Has anyone of you have experienced the big data? Anyone? Okay, so any data that crashes your Excel is a big data. Agree? Right? Okay, any data that crashes your database is a big data. Right? Why is it so? That we'll just check it out. But can you think of a word that relate you to your big data? Like when I say big data, what are things that comes to your mind? Give me the words. I will not ask you what that word means, but can you give me some words?
Web data.
Volume.
Web data. Website.
Web data.
Velocity, variety.
Okay, velocity, variety. But anything specific like
Hadoop,
what are things?
Hadoop,
Hadoop, yeah, very good.
Columnar data.
Columnar data.
So many things.
Do you know how many animals are linked with this data? With this big data? So you have an elephant, right? You have a pig, you have an impala. So we'll check it out. I'm not going into details, but you will see like what it is. So most of these things you will come to down the line. So what is the big data? See, any data that actually exceeds your processing capability, okay, because of the limitation of the existing conventional system is a big data. So when I took the example of Excel, Excel only has a capacity to process some n number of rows. If you require to process much more than that, we go to the database, right? SQL database. If in case SQL database also bombs, what do? We switch to the big data. Clear? So like I was just having a round and I asked some of the people like, what do you think about the big data? So some of the things that came out very well was like, okay, it's the social network data, the post, the feeds, the likes, whichever you give. That is just one type of big data. There is much more than that. So any data which exceeds the capability, it's a big data. It's big, right? The volume is huge. It's fast, okay, and it may or may not feed into your existing database structure. So what do you mean by that? In a Facebook, you can give any type of post. Every post will have a different meaning, right? Correct? So in one case, I will say, okay, I am giving my demographic details indirectly. In another case, I am giving you some intent of buying something or some other thing. So your attributes are different. So that's why it won't directly feed into your existing database. So why do we require, and why is this happening? Why do we require big data? Analysis, okay. So we require a big data for analysis. The problem is like the pace with which data is growing, with the same pace the computers are not growing. Agree? The upgradation of computers, the infrastructure, it's not taking the same pace like how the data is taking up. So if you see a social network, the number of feeds that comes in daily, the number of feeds that comes in daily, and look at the computers how they have grown up over the year of time. So that's why we have to go through a distributed computing whereby it replicates itself and then you start processing that, right? So this is just to give you an idea of a data volume. 1 GB is 1024 MB. Okay, so this is just like rounded off. It's 1000 megabytes. 1 terabyte is 1 GB, right? 1 petabyte is 1000 terabyte. 1 exabyte is 1000 petabytes, and so on. We have zettabyte and yottabyte. How many of you know this thing? I mean, like, come came across this thing? Okay.
You put the terabyte.
So right now there is data that is existing 3 exabyte, and it will soon go to zettabyte as well. Okay.
How many TB do you think we have in CAQT?
Yeah.
Across plants. You work the numbers there, you work on numbers. How many terabytes will we process?
You work on only data, not per
You don't work on. You've got 60 terabytes of production data across plants.
Does
In
that
this
include
office.
access? Does that include access?
Includes access.
Ah, that's
Does it include
That
customer
explains
sense?
it.
Does it include customer sense?
It doesn't include customer sense.
Okay. So are we near big data? We can move. I mean, we can go towards big data with more data feeds coming in, more data points coming in. So what are the characteristics of a big data? See, there are 4 main things which is associated with the big data. First is the volume. So when I say volume, it's basically the data size that comes in. Okay. So it's like data which is scaling up. Like right now, Kaushik said 60 TB. So it will go to petabytes as well. If more plans are coming in, we are exploring new things. So if that works out, then there will be some petabytes of data. So one is like big data is driven by a volume. Second one is the variety. So when I say variety, it can be a transaction data, it can be a data feed, a tweet, a Facebook post, it can be anything, or sensor data or machine-to-machine data. Okay. So basically, a structured, unstructured text, multimedia, all those things are variety. Velocity. Can you think of some good example of a velocity? So it's basically like, let's say if I walk into a store and there is a webcam. So there is a live stream, okay, Bhavin has entered the shop. So you should identify Bhavin and it should give some particular offer. Okay, so it's basically like the stream basically that is coming in. So it comes at a very fast thing. It's nothing that you take the stream and then you process the data and use the output. By that time Bhavin would have already left the store. So the turnaround time has to be pretty quick in that case, right? Are you with me? Yes. The third one is the velocity. So when I say velocity, it's basically the data usability, whether the data is usable or not. What is the data clean or not? Am I just bringing out some junk data? I mean, I have a huge volume, I have a huge velocity, I have a huge variety, but is that data usable? Does it require cleaning? Yes, no. So it all depends on what type of data you have over here. So that's velocity. Okay. So these are the type of big data. Okay, it's not only the social network data. These are the type of big data. One is the transaction. Okay, so when we say transaction, it's all the transactions that we work with. The customer's transaction, whatever he is buying, whatever transaction he is doing in his bank account, all those forms a transaction. Machine to machine data. Any examples? We have one live case in security for this. Nishad. Is Nishad around? Okay. So Nishad is one of the cases. I will just tell you why it's like machine to machine data. And third one is the human interaction data, which is like the data generated by humans. Post, feeds, content, likes, all those things. Okay. So when you say transaction data, right now what we do is like we just do our prediction modeling, all those things on a sample set. Okay. So imagine if we are able to do it on a full set, which consists of TBs of data. So big data will actually give you like faster analysis for those transactions. It will be much more quicker. You need not work on a sample. If your data size increases, the accuracy will also increase. So that's why how transaction data can be used for big data. Instead of sampling, just take out the whole piece and process those data. So machine to machine data. Sensors, right? If you see a nuclear plant, there are various sensors for temperature, for like whether something is going out of control or not. So there are sensors. This data actually gets logged every minute, right? So this data is an example of big data. Imagine how many sensors will be there in a nuclear plant, and when I get that data, I know that I can predict when this next thing will fail actually. So I can take corrective actions against it, right? Security devices, self-explanatory, smartphones. Can you give me an example of smartphone, like how can it be used as a machine-to-machine data?
Mobile banking. Mobile banking.
Mobile banking, okay, mobile banking. Anything else that will come as a transaction data?
NFCs. NFC.
NFCs, yes. NFCs will work out. GPS, right? You walk into the store and that information is transferred. Like, okay, this is the guy who is entered this particular store, right? So that's machine-to-machine data. So now can you tell me, like, what is the last part? Have you seen a bat in Nishal's hand?
Yeah.
Right? What it does is like it generates data about how much Nishal walks, is he having a peaceful sleep or not, how many times he is being disturbed in his sleep. So that's the data which is generated for Nishal. So let's assume that whole world is actually using that device. Now imagine the amount of data that will come in, right? So this is basically a machine-to-machine data generated by a machine and it's used by a machine. Got it? So this is another example of mobile traffic. Currently it's generating 3.8 exabytes. I mean in 2010 it was generating 3.8 exabytes. It's exabytes, right? And by 2020 it will be like 127 exabytes. So the pace is like, the point over here is like it will increase at a very much fast pace. So it's necessary to have that system in place. So by 2020 there will be 6 billion mobile phones, but 30 billion connected smart devices taking 42% of the mobile bandwidth. So that's the pace, like I wanted to highlight, like why the data is getting generated at such a high pace. Human generated data, social media, it can be used for cross-sell, upsell and identify churn. Let's say I want to say I am looking for a car. Okay, so there is an opportunity to sell something to me. If I am not happy with some XYZ service, I just point out, okay, I am not happy with this service. I am going to churn, right? So it can be used. Audio, whatever you speak, like let's say you are having a Skype call with a friend or maybe some meeting. So there can be, or maybe over a call center as well. So that audio will actually help you out, like what is the reaction, what is the sentiment of that particular customer. That can be used as a upsell, cross-sell and a churn. Email can be used for audit purpose, Kaushik, right? So there are a lot of data that goes over the email right now, right? Yes or no?
Okay.
It should not go. Sir, okay. It should not go. I mean, ideally we are not supposed to send any data over the email to the client because of the security purposes. So that all things can be.
There is an advantage to email analysis as well. Generally, what happens is if you do network analysis, relationship analysis based on who sends mails to whom, how often, and who responds to it, that helps in planning the capacity of the server to handle the emails. So people like Yahoo or Gmail, their core business work is still email. So what the whole group and HDFS came out of group. So what they wanted to know was who sends mails to whom, in which city, in which country, where do we host the data centers, where do we have the physical network connectivity. So all this is faster and semi-real time if you get into. Otherwise you will have to take a dump of all the data, spend 6 months doing the analysis, and by that time the thing has changed.
Right? You can also use it for documents. Right now, what is the time that we have? Like, if I want to have like all the CDNs and client servicing, if I want to have that single document upload, how much time does it take? So can I have an algorithm in place which will actually try to pull out the meaning out of that document and give a fair idea to the legal guy? Okay, these things are right, these things are wrong, so that turnaround time can be higher, right? So you can use it for documents as well. Videos and images. This was actually used during London Olympics for avoiding the terrorist attack. So how did it work is like whoever is coming in, okay, so they used to take a photo of your, they used to take your photo and they used to recognize it with the list of terrorists. So they come to know whether this guy is already in our list or not. So it was much more faster. The face recognition algorithm was more powerful. Second was the video. So they used to check the movement of a car, like how the car is moving. If there is some deviation from the normal movement, so they know that there is something wrong with this car. So that could be possibly a terrorist plot. So this is how they use the big data using video. right? Interesting? So let's go through some of the big data use case. It's basically the use case, not a case study, just to give you a flavor like how the big data can be used. So these are the various things where big data has been used. I have picked up some only some case studies. I will forward you the PDF which has actually many more case studies. Okay. So first is a case study of a Club Mahindra. Just think around. Okay. So the problem with Club Mahindra data, I mean the problem with Club Mahindra was like during the monsoon season the reservations used to go down. Okay, it was more targeted towards some fixed location. Something like Lonavala, just random example. Lonavala used to have there is no Club Mahindra in Lonavala, it's just an example. Let's say if it's a rainy season, you would like to go to Lonavala and like you would not go to some other place. So there was a problem that I wanted to recommend next waste holiday resort to its member. I mean, if I know that okay, Akash is going to Lonavala, can I divert him to some other location, some other resorts? Okay. So what we did was like we used to find out all the resorts with which Club Mahindra member has holiday. So I know like which of resorts Akash has visited. I will find the similar resorts where other people have visited. And there was some cosine thing that came into picture. Akash, can you just explain this cosine? Like what actually does it do?
So it basically it starts the matrix where you make a matrix of all members and all the resorts he's visited, and then for every resort you basically find similar resorts based on the dot product of the two matrix. So it gives you a similarity score between the two resorts.
Okay. So let's say if I am going to Lonavala, I have gone to Kumbhalgarh, then it's probably that I am more affine towards OT. So I should get an offer with the OT resort so that I go over there and not to Lonavala. Okay? So then we used to actually recommend 3 resorts. So what happened with the SQL query? Okay? We wrote a SQL query to perform these simple steps. Okay? It estimated like 64 days to complete and to give you the output for each of the customers. Okay? And client required this in 2 days. 64 days. So if I start my query today, I get output after 2 months. Okay? Then we have strong SQL guys, like they tried to optimize those queries. We brought it down to 21 days. Okay, so from 64 days, we brought it down to 24 days. Still, it was not acceptable. So how do we do it? So our last resort, Mr. Kaushik Janardhan, right? So basically, we decided to use Hadoop to leverage its processing capabilities. It took 4 hours to complete. Okay, this whole thing, which was like 64 hours in SQL Server, it took 4 hours to complete using Hadoop. So we have one live project that has been executed on Hadoop and we have got good results for it. Okay, so the number of members were 25,000, the number of resorts were 40, and these are the approximate number of calculations that were being expected. So Hadoop did it in 4 hours and SQL like optimized way took 21 days. Kaushik, would you like to just...
So basically what happened was we built the cosine logic in SQL and we did a trial run of, I think we did it for with about 6,000 records, and we extrapolated it and it came up with this 21-day count. So that's when Bhavin and Bharat suggested let's explore Hadoop. So we created a Hadoop cluster on the cloud, and Bhavin will go through it because it's hardware intensive, we couldn't do it internally. And we used Microsoft's Azure platform, which has a pre-built Hadoop deployment infra. So it's on demand. You create a 4-node cluster or an 8-node cluster or a 2-node cluster depending on your size, and we got the thing implemented. For this particular recommender model, we did not build because of time constraint and internal recommendation algorithm. We used a pre-built Mahout package as part of your animal library of Hadoop.
Yeah.
And that comes with a set of algorithms that gives various recommendation models. It could be cosine similarity, it could be Pearson coefficient. The analyst guys will know better than these things. So it makes your job that much easier. That's how we could bring the time to around 4 hours for this data set.
So Apache Mahout, it's an analytics library, right? So you already have a predefined set of algorithms over there. T-Mobile, okay. So it's basically from a communication industry, right? So what they did was like they used multiple indicators such as billing and the sentiment analysis to identify who are their high value customers, and they actually had relationship managers for them to take care of them, right? So whenever it's like they identify high value customer, the team focuses on that customers to retain them, right? So if I know if Akash is my high value customer, I will constantly check what Akash is saying about T-Mobile, how is he like reacting to all the offers and everything. So I can take like whatever record exchange is there. So this company basically the main objective was to retain the customers. Nestle. So Nestle actually they are again like very dependent on social media. They used to actually continuously read social networks for all the comments like whichever customers puts in, and to better keep track of what customers is saying online. There was a 24/7 monitoring service that they have. The company will actually engage with those that post about them online in order to mitigate that damage as well as build loyalty. Does anyone remember a case of Amul that happened recently?
Yeah.
Right? So what happened was like the milk was actually got like yeah. So what happened? The milk actually it became a dove kind of thing, and he posted on a Facebook that this is what is done and this is what actions they have taken. So in order to retain their image, the Amul team went to that customer's home. They checked the expiry date. The milk was already expired. So they have to like continuously keep track of all these things, like who is writing what about the brand, and it actually went viral. So that's how similarly the Nestle is also taking care of its brand image. McDonald's. So what McDonald's is doing is like if you see the McDonald's in India is different from what McDonald's is in US. The tastes are different, the menu is different. So they continuously keep track of like how is the design of the drive-thru, what is the information that is provided on a menu. The menu is different everywhere, okay, country-wise. What is the wait time, what is the size of the order, and they check the ordering pattern. And based on that, they actually optimize each restaurant as per the particular market. Got it? So the objective over here is like if I am setting up a store in India, am I having the right parameters? Am I having the right taste? Am I having the right menu? So that's how McDonald's has used this Hadoop big data as a optimization thing. Starbucks coffee. What they did was like they wanted to check whether everyone is interested in their products or not, right? So they actually used to check the trends, like if a particular customer is getting disinterested in their product or not, and if he is disinterested, they actually used to give a proper offer to that particular customer. So it was more at a customer level and not on a segment level. What I like understand. Walmart. This is an interesting case again. So what Walmart is trying to do is like it is trying to understand the context of a feed. Okay, so something like if there is someone has written a salt in a feed. Okay, so it will try to identify whether that salt is related to some particular movie or it is actually a condiment. So they use actually data analysis to identify the context of the message. Say I can say anything. If I say a sentence, it can come out as a positive thing. It can come out as a negative thing as well. So it's very important to identify the right sentiment. Right? If you don't identify the sentiment correctly, you will end up giving the wrong offer and probably you will lose the customer. Agree? Any questions? Okay. Procter and Gamble. This is again an interesting case study. So what they have done is they actually like before releasing the product, they actually go through n number of iterations to identify what is the right thing. So something like if it is a disposable diaper, what is the best design for a disposable diaper? So they are going till that level. If it is a dish soap, okay. So in that case, they will actually do all the iterations and how the moisture actually reacts with the molecules and give out the right fragrance. So they design the product accordingly so that when you are actually cleaning up anything, so at the right time you will get the right fragrance. So that is basically like more of a customer experience, I would say. That's how the big data is being used in Procter and Gamble. Coke, okay, another interesting case study. So in order to ensure that throughout the year you get the same taste for Coke, what they do is like they use the satellite imagery. They use crop yields, like how my crops are going to come and everything. And based on the customer's preferences and the flavors, they actually choose the right blend. It's not something like it's a set process and it continues to go on. They have to change the proportion every year based on how the climate is, how the crop yields are, and that's how they are using this big data. So on a daily basis, they are actually keeping track of temperature, X, Y, Z, many things. Amazon. So Amazon has a different thing actually. What Amazon does is like it uses big data to predict the security threats. So Amazon already has like around 1.5 million items. Agree? So if it goes into a warehouse, it gets stolen, right? There are chances that someone will store that product. So actually they predict like which products are more likely to get stolen. So based on that, they will take precautionary action against it. So they are using actually their cloud system actually to predict which product is more likely to get stolen, and accordingly they will decide the placement of that particular product. Discovery is again it's an insurance firm. So what they do is like they will actually try to identify whether the claim that is coming in is a proper or not. So it might happen that the treatment is very small but the claim is very huge. So based on all the data they have for the past history, they will take this particular case against that whole history, and they will come to know automatically whether this claim is a false, correct or wrong. So that brings up the turnaround time. The decision is very quick. It's either yes or no. Has anyone heard of this company? Okay, it's again a travel company. What it does is like it will actually try to tell you, it uses predictive modeling to tell you when will the cost of airline will drop in the next week or in the like they actually predict the cheapest flight amongst the popular destinations, popular airlines, all those things. So their algorithm is a self-learning algorithm. So it actually takes the input of the past history, predicts like which is the cheapest flight, and they actually like after that they try to do a conversion whether that prediction was proper or not, and based on that their algorithm actually like self-learns. John Deere. Any idea of John Deere? And like, have you heard of this company?
Tractors.
Yeah. It's basically we can do this for Mahindra farm. It's way right, but we can still see this. So what John Deere has done is like they have placed sensors on that on their equipment, and what that sensors will do is like they will start collecting real-time data. So that will actually help the farmers to identify like when is the right time to put a crop or when is the highest yield. It helps them to optimize their actually daily cycle. Right? Any questions? We have completed the use cases. Is the presentation syncing everywhere? Right? Okay. So this is basically what we call as Internet of Things. These are the things that generates data. Okay. Look at peacefully. I will be sharing this presentation, but I will just take you through one of the case. So we have a service sectors, we have the application groups, we have the locations, and we have the devices. So if I take an example of a retail service sector, let's say stores. So what we have is like we have a shopping store, we have a single site. Okay. So how the data gets generated in a retail form? It can be a POS terminal, right? It can be a cash register. So these are the various devices that will actually help you generate the data. Similarly, these are all the devices that generates the data across sectors. So imagine how the data will grow over the period of time. So we are done with the big data. Any questions? Everyone is clear? Right? So we will be able to sell big data now. Right? Okay. So let's move to Hadoop. What is Hadoop? Hadoop is nothing, it's just a system, okay, to process the large data. Right? So that data can be in gigabyte, terabyte, petabyte, and petabyte about. Okay. Hadoop basically uses two main concepts. One is the map radius for computational purposes, and second one is the HDFS, that is Hadoop Distributed File System for storage. Right? We'll check it out what it is. Can you install Hadoop? Like, is it an application? Can you just double click and your Hadoop? comes up. Any idea? Hadoop is not a software, it's a system. So this is one small Hadoop cluster. This is how it looks like. These are all your machines. You can see all it as a machine. Everyone is like connected, right? So we just have a small rack. This is right. So this is a small cluster. If you check the Facebook data cluster data center, it will be like you don't have a place to work. There is a one big rack over here, one big rack over here. So this is how the Hadoop cluster looks like, and that's why it's being given as an online service. If you want to have an in-house Hadoop cluster, we can have it, but it's very, very costly. So basically, when you use this Hadoop, you actually pay per cycle or pay per calculation. It depends on what type of package you take. What type of package do we have?
We have a 4-node cluster deployed, which is capable of processing close to 100 gigabytes in about half a day. This includes 16 cores of processor. It comes with around 128 gigabits of RAM, and storage is on demand, so it depends on your size. So I go with, for our requirements, the default storage of 1 TB is sufficient. If need be, we can add.
So, like if I want 2 more clusters, I just need to tell the cloud, okay, now I don't want 4, I want 6. So you get it immediately. There is not something like if you want 1 server over here, it takes a lot of time, right?
Theoretical max is around 4,000 nodes. You can have 4,000 physical nodes on one.
So all these things is one node. 1, 2, 3, 4, 5, 6. They are all nodes. We'll see what are nodes actually. Okay. So what is the map radius? Map radius is nothing but a framework that allows you to process your code parallelly, right? Something like if I want to process 10 GB of data, let's say if I put 5 GB of data on first computer, 5 GB on second computer, it will be much more faster, right? So this framework basically helps me to do it more efficiently in a better way, and it's very easily programmable. So that's why it's called as a simple straightforward model, which is based on the map and radius concept. So first you actually map it like 5 GB of data on computer 1, that is actually the mapping. Once it does the processing, it will come back to me, it will say okay, this is the output, second will give me the output, third will give me the output, and then I just collate it. So that collation is basically the reduction. So it's called as the radius, right? So there is a mapping phase and there is a radius phase. So let's say this is my document, okay? So document is like these are the text in each of the documents. I want to count in this all the documents, like how many times a word is appearing, right? So if I say week, in this whole set week is appearing only once, so my output should be week 1, right? Any idea what is so special about this text? Yeah. Okay. So this text is basically it contains all the alphabets. Okay, so whenever you want, there is a new release of fonts or something like that, they test it on this sentence. So they come to know, okay, all the alphabets are correct, right? Okay. So let's say I want to count the words. So I'm not using map radius. So how would I ideally do it? Okay. So I'll count the words over there in that first document. I'll split the words in the first document, second document, third, fourth, fifth, so on. Okay. And then I will just pass it to on one of the servers. This is how I would ideally do it. Okay. So this server will now have a list of all the words, and this server will actually do the summation, right? So this is going to take time because everyone is like first we are passing the data over here, and now this guy is overloaded with all the words. So this is just a sample image, like all the tweets I am sending to this server. Okay, across whatever tweets are generated today, all the tweets are going over here. It will take hell lot of time. Okay, and this is what the output will be. This server will finally say, okay, this word is repeating 5 times, 3 times, 2 times. Okay. How does map radius work? Okay, so what I said is like if there is any document, when you map it, it will give me a key value pair. We'll see to it how what it means. Okay, and then there is sorting, distribution, and regrouping, and that goes to a radius space, and it will give you the final output. Okay, so I'll let's see what exactly the mapping does. Okay, so when I map it, okay, this goes to mapper. Okay, it will give me output like this way. Okay, the is appearing once, week is appearing once, brown is appearing once, and so on. Now let's say like I just regroup it and this is the output. What it does is like it collects all the across the document. So this server is done its job parallelly. This is done, this is done, this is done, and the is accumulated parallelly. So across the text, I know that it is like the one. This is the output from server 1, server 2, server 3, server 4. Everything happened in parallel, right? Similarly, the other outputs are this way. You get a key value pair. So this is what a mapping is, and this is the output of like these are the maps of blocks, I would say. Okay, and then these are actually distributed. I mean, the becomes one block, database becomes one block, feature becomes one block, and then it's given to a reduce function, a reduce component. What it will do is like it will tell me, okay, the comes 5 times, database comes 2 times, feature comes 1 time. So this approach becomes much more faster because everyone is actually doing a calculation. Got it? Bouncer. Yes. Right? Understood the concept? Like the art of Hadoop is not actually implementing the code. It is actually the main art is like how do you define your map and reduce. In this case, what we have done is like every word is given to a reducer. Okay. So based on a problem statement, you can have 10 mappers and 2 reducers, or maybe a 2 mapper and 10 reducers. That's something you need to take a call on. But the main art is like how do you write a mapper and how do you write a reducer. The implementation is simple. The logic is important.
Amit,
Yeah.
I don't know how I can map this with
Can you be a little louder, please?
Okay, see, we are planning to start a distributed call center for Hyderabad.
Yeah.
Okay, Bombay, Delhi, and Chennai. That means we are planning to start an operation in Bombay, Delhi, Chennai. Suppose if any case Delhi and Chennai operation is shut down,
Yeah.
downtime is there. And if in Bombay the entire history period have to see, then you can see with the help of this.
Yeah, you can see. Say your source data is changing, right? The calculations, everything is remain the same. So whatever you are giving as an input, if you give only Bombay feed as an input, you will get result for Bombay. But if you give Bombay, Delhi, and other cities, then you will get the whole thing.
No,
So
for example, Bombay, Delhi, Chennai. In 3 places, in one operation is there. Okay, Chennai and Delhi, the operation, there is a downtime and customer is calling on inbound. Can Bombay agent can see all the history of the customer?
No. This wouldn't work for that kind of.
No, because here we have mentioned that there are 3 servers, then you can map whatever the history.
This is purely a calculation, aggregation. It is not a router. What you need is a router.
Right.
Something goes down, you route it to
Wait,
something.
backend-
That's more of a network appliance. This is more of a computation.
okay, it was a good question. So I'll just repeat the question. What Chito asked is like, I have a call center in Bombay, Delhi, and Chandigarh, suppose. And if Chandigarh goes down, can I route all my calls to Bombay? Okay. So this system actually does the work of a routing. This system is designed for analytics, for computation basically. So when you do a computation, your logic is predefined. It's not used for routing. It's used for analytics basically. It's used to generate the insights about the data. Addresses your question, right? Got it? This is something unexpected. This video will disappear in 4 seconds. I don't know. Okay. Okay. So this is like something you need to know in Hadoop. So whenever you go at a client side, just use these terms and you will be impressed. Right? You say, okay, Hadoop has a map reduce layer. Okay. It has a HDFS layer. Okay. There is a job that goes to a job tracker, something like I want to find recommendation for some resource. So it goes to a job tracker. What job tracker will do is like it will pass the task to a task tracker. Okay, and task tracker will actually use the data on this data node. Okay, to give you the output. These name nodes will make sure that these data nodes are up or not. If it is not up, it will assign some other data node. Okay. So we'll check this thing in a better way. We'll see these things in a better way. Okay. So this is how this just memorize these 5 terms. Say कि map reduce करना पड़ेगा, HDFS setup करना पड़ेगा. Use these terms. You will surely get an order. Right. So. Right.
Is it that simple?
It's that simple. So what is the job tracker?
Difficult job comes after that.
Okay. Yeah. So what is the job tracker? It is just a master who creates and runs the jobs. Right? So as soon as I get a requirement, as soon as I implement a Hadoop thing, I will just create one job and I will execute that job. What will this task tracker do? It will actually continuously go on asking, काम हुआ क्या, काम हुआ क्या, काम हुआ क्या, and it will just update the job tracker. Right? Okay. So these are the two types of services basically for MapReduce. Okay. Second one is the node. Okay. So when you say node, it's actually your cabinet. Let's say your cabinet is one node. Okay. So it's all the servers that you see, they are the nodes. One is the name node, which will actually tell you like what data is stored on which node. Something like let's say if I have a big file, I split the file. Okay. I will take the example of that 5 GB data. I have given first chunk of 5 GB data on computer 1, second on computer 2. So basically I am the name node because I know that first 5 GB is on computer 1, second is on computer 2. Right?
And is it like an index in a book?
It's like an index in a book. So you actually know like which chapter is starting at which point. Okay? So that's a good example. Thanks, Sridhar. Okay? Then there is a data node. Data node actually stores your data. Okay? So whenever you have a big file, you put it on a file system. That is basically a data node. Okay? Bouncer? We'll come to it later. Okay? We'll take this discussion down the line. What is the HDFS? Okay, anyone know what is the HDFS full form? Data wale mat bolo. I just said in the beginning.
File system, data file system.
Okay. It's a Hadoop distributed file system. Okay. So what does it do? It actually provides you the file system functionality whereby you can create file, delete file, write a file, read a file, and so on. And this is how the commands look like. This is to list all the files. This is to make a directory. It's similar to DOS, right? In DOS also you can, if you do a dir command, you get a list of files, directories. MPD is used to create a new directory, right? So it's pretty much simple like they are called as a command line tools, right? So how does HDFS work? Let's say I want to store this big file. Okay, I want to process this big file. Okay, this contains like let's say I want to count all the words over here. So how does the HDFS store this data? It will actually split all the data into small chunks, which are called as blocks. Okay, so the whole file is now split into 3 different files or 3 different blocks. Okay. It will actually replicate those blocks, right? So instead of one file, now you have 3 files. Okay. So this is the first block, second block, third block. Okay. And then this is all the data nodes. So it will keep one part over here, some blocks over here, some blocks over here, and some blocks over here. Why is this required?
One goes down, then access.
Sorry.
Okay, faster.
Faster, okay, faster access. Anything else?
कोई नोड डाउन होगा तो दूसरे नोड से वो
Correct.
कर लेगा.
Yeah. Let's say if these nodes goes down, okay, blue is not there, red is not there, white is not there. You still don't lose the data. What you will do is like you will start picking it up from different nodes. This is what a name node does. Name node actually knows where which part of my data is on which server, right? So if this node goes off, ये बंद हो गया, you will get it on some other node. So this is what the name nodes does. Basically, the interaction and coordination whereby it will ensure your success. So the up rate is high in case of Hadoop. Okay. These are the terms. Okay, this is optional. You can just buy up these terms as well while doing a client pitch. Okay, so you can say, okay, there is a Amari which does deployment, configuration, and monitoring of Hadoop. Okay, it's more use it more like a dictionary, right? So there is a Flume. Flume is a model which will actually log an event or all the data that is happening on your Hadoop system. Like whenever there is a process, it will generate a log. Right? There is a edge base which is column oriented data. Okay. So in case of column, how the data goes into the database. I mean, it's not actually a structured data. It's more of a key value. Something what we saw in a dictionary like the was coming once, so it was like PHE1. Okay. If I want to store my details in the database, in a column database, it will be stored as name, Bhavin, age, something likewise, and it will give you all the details. So it's more of a key value, like how you see the form, physical form, right? Name, and you are supposed to put a value. Then there is some other demographics, you put the value. That is how your columnar database looks like. Then there is a hive. the purpose of Hive was you are good at SQL, right? So people are not ready to write all those complex jobs whereby it will say, okay, I will do this. So Hive is basically a SQL type interface. You can actually write a SQL query and internally it will transform it into a Hadoop job, right? So it's more simple. So because of the Hive, more people are like easily migrating to Hadoop. If Hive was not there, then you will actually require a very good programmers who will actually code it in quite a detail. Mahmoud, we already discussed this. It's basically a library of machine learning and data mining algorithm. Ma'am, did you know? Pig. Okay. So Pig is basically a programming language for Hadoop computation. So one is like you can use Hive who are good at queries. If you are good at scripting, you can use a Pig. Ignore it, not for a CDNs and client servicing. Okay. Same is with Cozy, you can ignore this part actually. Okay. Cozy is something like a workflow management. How the task moves, where the task moves, you can just configure that. Scoop is basically it imports the data from a relational database. So let's say if you have a SQL server, I want to push that data into a Hadoop-like structure, I can use Scoop. Then this is like Zookeeper, which is again a configuration management and coordination. Right? So just like register these terms and what does it do. Rest of we will take care of it. Okay? So this can be useful. Okay, so we are coming to the final question mark. Any questions?
Does everybody know how the name Hadoop came?
How the name Hadoop came? I am not aware. I'll check it out.
Yeah,
but I know
I
it's
know.
the name of a toy of the. No, that was the yellow elephant. Yeah. This Hadoop, okay, it's missing over here. Okay. So here, like when you say it's not Hadoop, actually it's Apache. Okay, so that yellow elephant, you will see like whenever there is a Hadoop, you will see a yellow elephant. There's nothing like that. The guy who got this idea of like solving this problem, his kid was actually playing with a yellow elephant. So he took that up and that's that like yellow elephant. Like from that point onwards, yeah, whenever you see yellow elephant, you know it's a Hadoop.
It's the name of the toy.
It's the name of the toy.
The name of the pet was Hadoop,
Yeah,
so they
its
called
pet
it.
name was Hadoop.
Thanks. Thanks. So let's check this out. Like, are you clear with name node, data node, job tracker, task tracker? If not, don't worry. Like,
Tell us something. There are two types of people out there. Okay, one kind of people who are moving towards big data because there is a need, and there are others who are going there because it's a hype created out there.
yeah.
So what kind of client should actually go for something like a big data and a Hadoop kind of work?
See, it's simple as that. The first example I took is like any data that actually crashes your Excel is a big data. Okay, so let's say if in your case there is some demand from client whereby we are lacking the processing capabilities with the existing server. Okay, so in that case you can go for the big data. It's a classical Hadoop problem. Okay, but if there is a thing whereby client the data might be huge, but you just require like
Still can manage it.
yeah, you can manage it. So you need to check two things, like one is what is the volume of the data, what is the turnaround time on the data, what is the turnaround time to view the output basically, and that two parameters should actually help you finalize whether I should go for a Hadoop thing or you can do it on a SQL or maybe on an Excel or maybe on your fingers, right? Counting started with fingers. Anything else? So this is something random attempt. Okay, so this is a client. Okay. And this is our client servicing team, right? So whenever we meet the client, the first thing client says is like, I want to execute 10 campaigns by today EOD. Okay? And this is what like, okay, we are running short on time. And the next thing is like, I have a business impact, I want to do it by today EOD. So what does it do? I mean, they have a meeting and this poor guy comes to a CDM. Okay? He says, okay, you are 10 campaigns, please get it executed by today EOD. And what he does is, it's unrealistic, right? So how do we handle this? I mean, we have to execute 10 campaigns today. Let's move inside today. Okay, go. Right? So what happens is like, we have a team over here, okay, 10 campaigns. So I get one more guy. These are a team of campaign executives. Got it? These are another team. More number of campaigns, so more people over here. Okay? This is a team of campaign analysts. So the task gets divided. Everyone takes up 2 campaigns, 3 campaigns. These are the senior data analysts. They use Jira and CMO. Okay? And the 10 campaigns gets executed. executed. So what happened actually? If you see all the roles, I mean, sorry. Okay, so if you see the role over here, these are client servicing guy. Okay, these are CDM. These are the senior data analysts who assist the team. Okay, his job is to make sure that 10 campaigns, like whatever, like HTMLs are ready. The job of these guys is to make sure that okay, my data is coming out, everything is ready. So what he has done is like the turnaround time was less, the volume was huge, right? In a day, 10 campaigns. So what he did was like he borrowed some resource from other team. He distributed the campaigns among all the team members, and the campaign got executed. So this is similarly how Hadoop works. Let's see what this things are. So he is basically a task tracker type of thing. You can use these as a data node. Okay, the CDM can be seen as a name node, and the client servicing team can be seen as a job tracker. Why? Because what this job tracker does is it actually creates the job. What is in this case? It's the campaigns. If I want to if I'm just having the analogy, right? These guys are 10 campaigns, right? So what this job tracker does is it is the master who creates and runs the jobs, right? Got it? It actually runs the task and reports the status in job tracker. So the role of the CDM is to ensure that all the campaigns are going out. So he needs to constantly update CDM. Okay, I have the creatives right, I have the data right, everything is right, everything is in place, and he actually updates the status to client services. Okay. Name node. So what does name node does is it keeps track of which data node is on which data node is the data store. So if I know there are 10 campaigns, I know that first guy is actually doing campaign 1, 3 and 7. Second guy is doing 2, 8 and 10. So this guy knows everything. Okay. Now suddenly this guy says, okay, I am going on a 1 week leave. What happens? This guy knows that this guy is going on leave. He will go to the other CDM. He will say, "Meko resource thing." Right? So what happens is if there is a failure, okay, you actually get a different resource. Got it? Are you with me? So it ensures that your campaigns are going out. Data node, it actually only stores the actual data. So they are actually, when I say data, I can call it as a campaign. So they only have the campaign details, campaign information. They are not bothered about what happened about the data extraction, what happened, whether campaign is out or not. They just know, okay, this is what I am supposed to look after and look after that only. So it actually stores the data. So now you are clear? Okay? Sorry. So this is just a concept and analogy used to help you understand Hadoop. So what are tools I have used? This is the question mark that for this presentation. First is I have used Movely for creating this animated video. Right? It took me 3 hours to build a story and get this thing in place. I have used Specify to broadcast my presentation. So if you see, there are presentations that are broadcasted over there. Okay? And the advanced presentation remote app, I am using my smartphone as a presentation remote. Okay? So this is what I have. Thank you. So the thing was along with the data, big data and Hadoop, I wanted to improve something on a presentation. So you can actually now, if you have a client presentation, you can just create a video. It's very simple. It's just like a PPT. You just need to show how, if you have a video given to your client, imagine the charts coming up, all those things, the customer is churning, new customers are coming, everything. You can show it in an animated way. It's very simple. This was 3 minutes video. It was 3 hours, but it was for the first time. Since I was doing it for the first time, it took me 3 hours, but I think you can improve on a time, right? You can use that. Similarly, Specify will help you actually keep all your clients connected. The problem which I saw normally during all the presentations, people behind the pillar, they used to do this to see the PPTs. So I have to broadcast it. This thing you can actually check on your mobile as well. So this link will actually help you keep your audience engaged with your presentation. They don't need not worry like whether I'm able to see the slide or not. They can directly view it on the mobile as well. And the third one was just for time pass, like use smartphone as a remote control. It's very simple. I mean, you just need to plug in and you can control these things. I think yes, you can control things. Thank you.